Hey everyone, Chris here with C&D Solutions. Today I want to walk you through a small side project we recently took on. We needed a way to hold smaller round stock with high precision and repeatability. I've always enjoyed using the hardened cold close relays at a previous job, so we set out to create something similar for our Clausing-Colchester 1550. The plan was to adapt an off-the-shelf ER40 set-true style collet holder onto our lathe, which uses a D1-6 spindle mount. We started with a D1-6 backplate blank, an ER40 Collet chuck from Shars, and a chunk of 4 1/4 1018 cold rolled steel round stock. From there, it was just a matter of making it all work together. Let's jump in and take a look at the build. The first step was to model everything up in SolidWorks, using the dimensions available online. We first modeled the D1-6 backplate blank, then the Shars collet holder. The plan was to make a press fit spud that would go into the D1-6 blank and allow a backing face for the collet holder to bolt onto. Unfortunately, most of the dimensions were just perfectly inconvenient, so I opted to put the bolts right through the interface between the two parts. I spread the diameters slightly outside of the press fit part so that it would be easy to drill them. Once it's all bolted together, I'm not too worried about the strength of the threads. I think they'll actually assist in holding the press fit together. The best part about being your own engineer is that you can be supremely lazy when making drawings. I didn't do any kind of tolerance callouts, press fits, or anything like that. I knew I would be making these dimensions in situ. So now the next step is to get into the shop and build some stuff. Our first step was to face off the raw stock and turn down the OD. I do apologize for the bad angle here. You're going to be watching my left shoulder for a while. I took a number of measurements when I was first starting. This is the first time I was using the new DRO, so I really wanted to make sure it was dialed in. Finished doing the OD here and moved on to doing the nose piece. Unfortunately, I didn't get video of all of that because it was taking quite a while to cut down. You can see some blue chips coming off. I was definitely running pretty fast and hot, but seemed to be doing okay. I think I was taking about 100 thou diametric off on each pass. Next step was to drill out and open up the center bore. I was drilling to about 1.5 inches deep, knowing that I would eventually part it off at 1 1/4. That's about 1200 ripums. The lathe takes a little bit to spool up because of the amperage limitation on the VFD. Little test fit. Don't be alarmed by the excessive play that needs to be there for the set true adjustment. Never really had good luck with parting tools. I was using a high-speed steel cutting blade on this, and I just couldn't get it to work well. After I got about a 1/2 inch deep, the work kept trying to ride onto the tool, and raising, lowering the tool, changing RPMs, nothing really helped. So I ended up just cutting it off on a bandsaw. Just taking it down to its final depth. Next step is to turn down a slip fit OD that slides down into the existing bore of the D1-6 blank. Always a good feeling there. That's about 2 or 3 thousandths clearance. Time to remove the 3-jaw chuck and put the D1-6 blank onto the lathe so that we can machine it directly in place. Doesn't look it, but that thing's pretty heavy and kind of awkward to carry. I'm also generally an office worker, so I won't be winning any strongman competitions anytime soon. Getting ready to work on the internal bore here. This is going to be a press fit, aiming for about 4 thou, over 4 inches. So this needs to be kind of precise. I find out as soon as I make the first cut that the ring is some kind of cast iron or cast steel, so it's basically just throwing a bunch of hot powder off. And time. Before I started machining the D1-6 blank, I put the other part in the freezer. So here I am heating this one up with the torch, and I'll run and grab the other part and throw it in there and see if she presses in. Parts went together really nice. Really looking forward to getting a big arbor press for the shop. The hazard front hydraulic job just didn't really do great. People tell me I'm developing a bald spot, but they're liars. I threw the whole assembly in the mill. I used 4 of the cam lock pins to hold it. Didn't really clamp it that hard since I was just drilling some holes. The DRO is a Chinese D-Tron DRO. It's pretty nice. I like the feedback that it gives when you're doing hole patterns or interpolated edges. Overall, I'd probably buy it again. Always good to double check before you drill the holes. I've been burned too many times messing up on that one. On my mill, I'm using what's currently a prototype, but it's a Modbus protocol VFD controller. It allows you to get visual feedback on spindle speeds and has some nice features like reversing. For tapping, it's great to drive the spindle in and then hit the button to reverse, but I wasn't about to risk that going into a blind hole, so I ended up starting them with a spindle and then tapping them by hand. If you're not familiar with the D-style cam lock spindle mounts, You basically have to put all the cam lock pins in, you line them up with a little scribe mark on them, and you put it on your spindle, tighten everything down, and if the locking lugs end up in the right place, you're good. If not, you end up having to take it apart and adjusting one of the cam lock pins by one turn, and then retrying. I left a little bit of extra material on the adapter so that I can come in and do a finishing pass once everything was pressed together. So here I'll do a final facing pass on the set true boss, a turning pass on it, and then a facing pass on the main adapter body. Just some finishing touches. And the moment of truth. Will it fit? I'm using the 4 set screws around the outside perimeter to dial in the run out. I didn't have any ground round stock, so I actually just threw a center finder in there. Here I am marking them just for a reference point. The process is basically iterative, but you go around and tighten all 4 corners. If the run out looks okay, then you snug up the nose piece, and generally it moves around a little bit, but you can tighten the set screws around the perimeter again to kind of lock it all down. And there's our final product. Less than half a thou of total run out. I think it turned out pretty well. I ended up using the tool to make a little leverage handle. Using the brake didn't work out as well as I thought it was going to on the lathe when you're trying to break the collet nose loose. Well, overall, I'm pretty happy with it, and we'll see you guys in the next one.